Is water wet? Well, obviously, to start off answering this question, we have to define what is wet. The first definition we can see on Google is covered or saturated with water or another liquid. So we're going to be using this as our definition from now on. Now, when I asked this question to a few friends of mine, one of them responded with this comment: water isn't wet. It's a description of our experience of water. Now, there's no real point to having this comment in the video other than I just want to call him out for plagiarizing Jacqueline Castle's. That's it. Fuck you, Elliot. Now, there are many arguments as to why water isn't wet. One of them I've called the fish argument. Is a fish is not wet until it leaves the water. What this is saying is basically there has to be contrast. The water has to be a layer rather than a surrounding material. And my argument for this is the surface of the ocean is the top of the layer. Where the water meets the fish is the bottom of the layer, just because there is a lot of water in between the surface and the fish doesn't mean that water cannot be considered a layer. Therefore, I would consider a fish in the ocean to be wet. The second argument I could find is wet is simply a state of having a residual liquid on a non-liquid object. And this pretty much fits with our definition of wet, and this is what I'm going to be covering in this video. But unfortunately, we're not talking about fish. We're talking about water itself being wet. And to actually go over this, I have to go over some theoretical background first. Now, in quantum chemistry, there's a thought experiment called particle in a box, where you basically trap a particle in a finite space so you can observe the quantization of energy based off of quantum numbers. I won't go into detail, but it's very good for describing systems such as an electron trapped in a conjugated pi system, such as 1,3-butadiene. It's also good for quantum dots. Now, what quantum dots are, they are effectively one-dimensional metallic substances. Now, in a normal metal, you have this electron here which can move in any direction. No matter which direction it goes, there will always be more, in this instance gold. There will always be more gold for it to move to, and one of the key principles, one of the key properties of metals is this ability, this sea of electron as is described in so many cases. When you move down to the quantum level, the electron can no longer move anywhere because it runs out of gold, in effect. And this actually changes the properties of the gold. These quantum dots are used in a variety of reactions, such as photovoltaics and whatnot. The point of the matter is, as we move from macro to micro, the properties of the gold changes. Now, if we were to consider water in this sense, a single molecule of water not surrounded by any other molecules of water would be considered dry. It's not covered or saturated with another liquid. But if we were to consider molecular water, surrounded by molecules of water, we could consider this single molecule of water in the middle to be wet. Unfortunately, once we move from micro to macro, you would consider all 5 water molecules to be water, and therefore the water itself would not be wet. To summarize, water is wet when considered in terms of micro, and not wet when considered in terms of macro. Water is both wet and not wet at the same time. It's an answer that satisfies no one and angers everyone.